So let me ask you something. You've seen Ant-Man, right? When he shrinks down and enters the quantum realm, where the normal rules of reality just don't apply. And in Avengers Endgame, they literally use quantum physics to travel through time and change the past. But here's the real question. What if that's not just movie magic? What if quantum physics is actually real? And even stranger than Marvel made it look. At the smallest level of reality, atoms, electrons, tiny particles, things don't behave the way we expect. Particles can be in two places at once. They can disappear and reappear. And somehow, just observing them can change what they do. I know, it sounds impossible. But this isn't science fiction. This is quantum physics. Alright. So what is quantum physics? Think of it like this. Everything around you, your phone, your body, the air is made of tiny particles. Atoms. And inside those atoms, even smaller particles like electrons and photons. Now here's where it gets weird. The physics we normally learn, gravity, motion, force, works perfectly for big things. Cars. Planets, basketballs. But when scientists started looking at really small particles, those rules stopped working. At the atomic level, things don't move in clean, predictable paths. They don't behave like solid little balls. Instead, they act like waves, like probabilities, like they're not fully there until you measure them. Quantum physics is the branch of science that studies this tiny, strange world, where reality doesn't behave the way common sense says it should. And trust me, we're just getting started. So here's how all of this actually started. Back in the late 1800s, scientists thought they had physics completely figured out. The laws of motion, energy, light, everything seemed solid. But then, something didn't make sense. There was a problem called the black body radiation problem. Basically, when scientists tried to calculate how hot objects glow, the math completely broke down. According to classical physics, the energy should have gone infinite, which obviously doesn't happen. Then in 1900, a German physicist named Max Planck made a bold move. He suggested that energy doesn't flow smoothly like water. Instead, it comes in tiny packets. Small chunks. He called these packets quanta. At first, even Planck thought it was just a mathematical trick. But it worked. The equations suddenly made sense. And that tiny idea that energy is not continuous, but comes in little pieces, became the foundation of quantum physics. One small fix, that changed science forever. So after Max Planck introduced the idea of energy coming in packets, most scientists were still unsure. Then came a young physicist named Albert Einstein. In 1905, Einstein looked at a strange experiment called the photoelectric effect. Scientists noticed that when light hits a metal surface, it can knock electrons out of it. But here's the weird part. According to classical physics, brighter light should knock out more powerful electrons. It didn't single quotes t. Instead, it was the color of the light, its frequency, that mattered. Einstein explained this by saying something bold. Light doesn't just behave like a wave. Sometimes, it behaves like tiny particles. He called these particles photons. This idea proved that light is both a wave and a particle. And for this, not relativity, Einstein won the Nobel Prize. Reality was officially getting stranger. Okay, so light can act like a particle. But here's where things get even stranger. A French physicist named Louis de Broglie had a wild idea. He said, what if it works both ways? If light, which we thought was a wave, can act like a particle, then maybe particles like electrons can act like waves. At first, that sounded crazy. But then scientists did an experiment called the double slit experiment. They fired tiny particles, like electrons, at a barrier with two small openings. If electrons were just solid little balls, they should have made two simple lines on the screen behind it. But they didn't. Instead, they created a wave-like interference pattern. Like water ripples overlapping each other. It was proof. Matter doesn't just behave like solid stuff. At the quantum level, it behaves like waves of probability. The universe wasn't made of tiny marbles. It was made of something much stranger. Now let's talk about something that completely changed how we understand reality. A physicist named Werner Heisenberg came up with a shocking idea in 1927. He said, "There are certain things in the universe you can never know exactly at the same time. For example, you cannot know the exact position of a particle and its exact speed at the same time. If you measure its position very precisely, its speed becomes uncertain. If you measure its speed precisely, its position becomes uncertain. This isn't because our tools are bad. It's because nature itself works this way. At the quantum level, reality is not perfectly predictable. It's based on probability. And here's the mind-blowing part. The act of measuring something actually affects it. So in a strange way, just observing reality changes it. And that idea? It shook the foundations of physics forever. Alright, now, let's make this even weirder. A physicist named Erwin Schrödinger came up with a thought experiment to show how strange quantum theory really is. Imagine this. There's a cat inside a closed box. Inside the box, there's a tiny quantum particle connected to a device. If the particle behaves one way, the cat lives. If it behaves another way, the cat dies. Now here's the crazy part. According to quantum physics, until you open the box and check, the particle is in a state called superposition. That means it's doing both possibilities at the same time. So, the cat is both alive and dead at the same time. Not because we don't know, but because reality itself hasn't chosen yet. Only when you open the box and observe it, does the wave collapse into one outcome. Alive or dead. It sounds impossible. But this is how quantum systems actually behave at tiny scales. Reality, at its core, isn't fixed. It's a set of possibilities, waiting to be observed. Now get ready, because this might be the strangest part of all. There's something in quantum physics called entanglement. When two particles interact in a certain way, they can become connected. Not just loosely connected, deeply linked at a fundamental level. Even if you separate them by miles, or even light years. If you measure one particle, the other one instantly responds. Instantly. No signal traveling between them. No delay. When Albert Einstein heard about this, he didn't like it. He called it spooky action at a distance, because according to classical physics, nothing can travel faster than light. But experiments have confirmed it again and again. Two particles. One shared state. No matter the distance. It's like the universe doesn't see them as separate anymore. And if that's true, then maybe separation itself is just an illusion. Okay, now let's bring it back to real life. Because quantum physics isn't just weird stuff in a lab. Today, we use it in ways you interact with every day. For example, quantum computing. Companies like IBM and Google are building computers that use quantum bits. They can solve problems normal computers could never handle. Quantum encryption, ultra-secure communication that hackers can't crack. Medical technology, MRI machines work because of quantum physics. Electronics, semiconductors, your smartphone, LEDs, all depend on quantum rules. Basically, the weird rules of the quantum world are powering the technology you use every day. And we're just scratching the surface. The future is about to get even stranger. So, where is quantum physics now? And where is it going? Scientists aren't just studying tiny particles anymore. They're using quantum rules to build the future. Quantum internet, super secure networks where information is instantly shared. Quantum teleportation, not like Star Trek, but transferring information between particles over huge distances. Advanced AI plus quantum computing, solving problems that would take today's supercomputers millions of years. Space research, precise sensors, better satellites, and exploring the universe at quantum levels. Every year, we get closer to controlling the quantum world. And what was once just a theory in labs is now shaping medicine, communication, technology, even space exploration. The future isn't just coming, it's quantum. And it's going to change everything. Surface. If you enjoyed this dive into the crazy world of quantum physics, don't forget to hit that subscribe button and join the channel. Also, drop your thoughts in the comments. I'd love to hear what you think about this weird, amazing quantum universe. Thanks a lot.